A computer defeats the world chess champion. That moment was not just a game, it was a doorway into the future of our decisions. Back then, rules and search brought victory. Today, it is learning. Intelligence spilled beyond the board, into language, vision, and sound. Now we face the real question: do machines think, or do they merely calculate? In this video, we will explore both their power and their limits. In the 1950s, Alan Turing reframed the debate with the imitation game. If an observer cannot tell, through conversation, whether they are interacting with a human or a machine, then what matters is not the inner workings, but the inability to distinguish. In 1956, a summer at Dartmouth bloomed with dreams: chess programs, translation, medical assistance. Then reality set in. Learning was slow, data scarce, computers small and expensive, funding cooled, and the first AI winter arrived. Decades passed, three forces aligned: the growth of data, the falling cost of computation, and renewed architectures. In 2012, AlexNet triggered a leap in computer vision. In 2016, AlphaGo made moves that seemed like intuition. In 2017, the transformer reshaped natural language processing. The answer to why now is this: the pieces finally met on the same board. A neural network does not copy the brain, it repeats a simple idea many times. Imagine thousands, millions of tiny adjustments, weights. The system looks at examples, tweaks those weights, tests itself, and tries again. The number of errors is called loss, the difference between prediction and reality. Backpropagation calculates each weight's contribution to the error and shows how much and in which direction it should be updated. Gradient descent makes small, steady steps to apply the updates. When you show it handwritten 5 and 6, the boundaries shrink and sharpen with each round. Yet perfect narrowing is dangerous: overfitting. The model memorizes instead of generalizing. It performs well on the training set, but stumbles in the real world. The remedies: regularization, data augmentation, cross-validation, and careful evaluation. Because the risks of memorization and data leakage never vanish. They can only be managed. Language models solve an even simpler task at an extraordinary scale, predicting the next word with probability. They do not just parrot sentences, they learn patterns, relations, and probability distributions within context. Power does not equal infallibility. When deprived of context or stretched beyond knowledge, they may hallucinate, confident, but incorrect answers. That is why you should ask for evidence, verify with external sources, and never remove humans from the decision loop. The right design is this: the machine suggests quickly, you select with context and values. Without us noticing, they are everywhere. You speak to your phone, the system transcribes words, infers intent. Streaming services and shops rank oceans of content. In hospitals, images pass through many digital eyes. A system may notice a faint shadow, but the final judgment belongs to the clinician. Trucks and planes find shorter routes. Small savings multiply. Cars read lanes, recognize signs, detect pedestrians. Silent helpers spread. Today's models are multimodal. They process text, images, and sound together. They describe a photo, transcribe a voice note, generate draft visuals from a sentence. In creativity, they are a new brush, but taste, purpose, and choice remain human. Let us ground this in two brief cases. First, radiology. A system highlights a small shadow on a chest X-ray, but it is a false positive, because an alert is not a decision. Protocol requires human confirmation. Second reading, comparison with prior scans, clinical history. The cost of a false alarm is a minute. The cost of a missed finding is a life. Safety is defined by who owns the decision, not who gives the alert. Second, credit scoring. past data carry past biases. If a model learns them, it produces habit, not fairness. The solution: clean the data, assign fair weights to groups, balance features and test outcomes with fairness metrics, like equal opportunity. The process must be transparent, with clear appeal paths and auditability. A model should be measured not only by accuracy, but also by the fairness of the lives it affects. Technology waves reshape work. Routines automate, some tasks fade, new ones emerge. Human-centered work rises in creativity, oversight, interpretation, and empathy. The successful pattern resembles a centaur. The machine suggests swiftly. You choose with context and bear responsibility. A teacher adapts reading material to class level with the help of a model. Assessment and pedagogy remain the teacher's duty. A lawyer gains speed in case law search. The final argument, with ethical and legal weight, remains theirs. A designer sketches a draft. The system offers variations. Choice and taste remain the designer's. Good use empowers humans while keeping responsibility in human hands. Meanwhile, the ecosystem splits into two streams: closed models and open source approaches. Closed models drive performance and speed productization, but transparency is limited, cost high, dependency heavy. Open source spreads accessibility, auditability, and customization, but brings operational load and integration responsibility. Which tool you choose shapes cost, speed, and accountability. In organizations, it is not just a technology decision, but a governance choice. Who can see what? Who can touch which data? How can errors be traced back? There is also a quieter cost: energy. As models grow, computation rises. Electricity use and carbon footprint increase. That is why more efficient architectures, purpose-built smaller models, retrieval-based methods, shared infrastructure, and clean energy become critical. Efficiency means not only speed, but sustainability. Techniques like quantization, knowledge distillation, adapter layers connect good enough performance with reasonable cost. You cannot manage what you do not measure. Energy tracking and reporting are now essential metrics. When something goes wrong, who is responsible? The developer, the distributor, or the user? The right answer is shared responsibility. In design, systematic risk analysis, data provenance checks, testing. In deployment, usage constraints, clear documentation, training. In operation, monitoring, logging, recall mechanisms. Transparency is needed not only in good times, but in failure. And as images and sounds multiply, the line between real and fake blurs. Deepfakes, cloned voices, generated images. Verification tools, invisible watermarks, content provenance chains, and open audits must form the new infrastructure of trust. Educating users, teaching media verification, and enabling rapid responses to fake content. These are duties of the entire ecosystem. Take a simple, everyday case. A farmer photographs his field. The system identifies leaf spots, pulls weather and soil moisture data from external sources, suggests irrigation plus low-dose nutrients, and reads the result aloud. The suggestion is speed. The choice and responsibility are yours. Once again, an alert is not a decision. Safety means clarity about who owns the decision. Returning briefly to the philosophical question, do machines think? As Turing pointed out, perhaps this is not always the best question. What matters is indistinguishability from the outside, practical performance, and alignment with human values. Today's models perform statistical inference, producing patterns and probabilities from context. That is not worthless. On the contrary, it provides speed and scale in many tasks. But power must be understood with its limits. Hallucination risks, data biases, energy costs, security gaps, and legal responsibilities. The first step toward proper use is proper naming. Ahead of us lie two main routes and countless paths in between. On one side, tools that empower teachers, support doctors, whisper weather and soil insights to farmers. Better health, cleaner energy, fairer services. On the other, invisible origins of decisions, surveillance as habit, speed outrunning thought. The future will not be the product of a single intelligence, but of our collective choices. Rules, standards, education, and ethics all shift the compass. Yesterday, we counted pieces. Today, the board is woven from language, vision, and sound. The rules have not changed. Speed belongs to machines, meaning and values to humans. The aim of this video is to show both power and limits. First understand, then decide. So, is AI merely reflecting us, or are we witnessing the birth of a new intelligence? Perhaps the answer lies at the intersection of both. The mirror you see will shape tomorrow's world, a world that will be the shared story of humans and machines. Consult, verify, document. Speed plus responsibility equals trust.